So, guys, so far we have been talking about relative velocity, relative velocity. Why don't we just generalize it to relative vectors? After all, velocity is a vector. Okay? So, what applies to one vector applies to all vectors. Yes. Remember, a vector is an element of a vector space. Okay? So, and every vector has components. That is every vector. Let's say this is a vector. It has a component in horizontal direction and also a component in what? In vertical direction. So this component in horizontal is Vx, while the component in vertical is what? Is Vy. So with an angle theta. Okay? So Vx, using the trigonometric ratio, we have that this is V, this is the vector V. This is the vector. So now we have that cos theta is equal to what? Adjacent over hypotenuse, Vx over V. So Vx is equal to V cos theta. Y sin theta is equal to what? Opposite over over hypotenuse, Vy over V. So Vy is equal to V sin theta. So this is the vertical component, this is the horizontal component. So we can depict it like this. We can say V is the vector, that is V is Vx, Vy. You understand? So where Vx and Vy are what? Components. Yes. So now we can apply this concept to relative vector. So let's say you are given two vectors, vector A and vector B. So you are given two vectors. Now vector A has component VA. The components of vector A are VAX and VAY. Okay, that's the horizontal component is VAX, the vertical component is what? VAY. And vector B is equal to VBX and VBY. Okay, good. So if they ask you the relative vector, that is the relative vector between the relative vector of A and B, that is the vector of how do I put it now? The relative vector of A with respect to B. So with respect to vector B. So see what you do. So that is VAB equals to, you subtract this thing, that is VAB equals to VA minus what? VB. So see what you do. So VAB is equal to, that is you have the components like this, that's VAX minus VBX, okay, and VAY minus what? VBY, okay. So this is the relative vector. If we want to find the magnitude of this relative vector, so the magnitude of the relative vector VAB is equal to the square root of bracket VAX minus VBX all squared plus VAY minus VBY all squared. Okay, this is the magnitude of the relative vector. Do you understand? If you want to find the direction of the relative vector, so we have that, see the direction here. We have that tan theta is equal to, tan theta is VY, that is that is VY over VX. Yes, this is tan theta, VY over VX. So everything, like, this is the Y component, okay? This is the X component. So tan theta will now be equal to, so which is equal to VAY minus VBY all over VAX minus what? VBX. Okay, this is tan theta. So which implies that theta, let me write it here, tan theta is equal to VAY minus VBY, over VAX minus VBX. So it means that theta is equal to the tan inverse of VAY minus VBY over VAX minus what? VBX. So this is it. So this is how to, another way to solve the problem, okay, on relative vector. Like another approach to it. This is like a general approach from the perspective of vectors, okay? Yeah, from the perspective of vectors in general. Yeah, so this is what you will be doing.